All right, welcome everyone to our virtual lab session. Today, we're not just going to talk about data analysis theory. Oh no, we're going to get our hands dirty and actually do it, step by step, with one of the best tools out there, Python. So go ahead and grab your virtual lab coats and let's jump right in. Okay, so take a look at this. This is our raw data, a simple table of student grades. Now, at first glance, yeah, it's just a bunch of numbers. But to us, this is a story waiting to be told. We're going to be data detectives, and our investigation is focused on two key questions. First, who's the top student here? And second, is there some kind of secret connection? Are the students who rock at math also the ones who ace science? So, here's our plan of attack. We'll start by setting up our digital toolkit, getting all our gear ready. Then we'll load the evidence, that's our data file. After that, we'll run the analysis, then visualize our findings to really see what's going on, and finally, we'll go looking for those secret connections between subjects. Okay, first things first. Just like in any science lab, before you start an experiment, you have to get your equipment ready. In our digital world, that equipment is a couple of really powerful Python libraries that are going to do all the heavy lifting for us. We really only need two main tools today. The first is called Pandas. Now, I want you to think of Pandas as a superpowered spreadsheet that lives right inside Python. It is absolutely brilliant for organizing and digging into data. Our second tool is Matplotlib. This is basically our robot artist. We hand it numbers and it creates these beautiful, insightful charts and graphs for us. And getting them is super easy, just one simple command. And hey, here's a quick but super important tip, just like any good lab procedure. For our Python program to actually find the data, your Excel file, in our case grades.xlsx, has to be saved in the exact same folder as your code. Trust me, remembering this little step will save you a lot of headaches later on. Okay, our lab is prepped, our tools are ready. Now it's time for the first real step in our investigation, getting the evidence. We need to get that data out of the Excel file and pull it into our Python environment where we can actually start working with it. Believe it or not, this tiny block of code right here, this is the key that unlocks everything. With just these three little lines, we can tell Python to open up that Excel file and pour all the data into a special container called a data frame. Let's break down exactly what each line is doing. So that first line, import pandas as PD, that's us calling our trusty assistant, Pandas, into the room. We're also giving it a shorter nickname, PD, just to make our lives easier. Then the second line tells PD to read Excel and store everything it finds in a variable we're calling df. Think of df as our interactive data table. And finally, that printdf.headline, that's our quick safety check. It just shows us the first 5 rows so we can peek at the data and make sure it all loaded in correctly. Okay, the evidence is in the building. Now this is where the real fun begins. We can actually start interrogating our data, asking it direct questions with our code. We're going to find out things like the average scores, the highest scores, all the good stuff. Let's get down to business. This next chunk of code is how we're going to get our first real answers. It's going to crunch the numbers to calculate the average scores, find the highest score in every subject, and even count up how many of our students are really high achievers. So how does it work? Well, first, we just grab the columns we care about: math, science, and English. Then the .mean command, well, that just calculates the average for each one. Simple enough, right? .max finds the single highest score in each subject. And this last one is a really clever little trick. Grades greater than 13.sum basically asks, hey, for each subject, how many students scored higher than 13, and then it counts them up for us. And boom, just like that, we have our first results. See, the data is already starting to tell us a story. You can see right away that the highest average score is in English with a 13.8. And if we look at the single highest scores achieved, we've got a tie between math and English, both with a perfect 15. Now, these numbers are great and all, but let's be honest. A table doesn't exactly scream insight, does it? Our brains are just wired for visuals. We understand pictures so much faster. So it's time to call in our robot artist, Matplotlib, to paint us a picture. And this is where the magic really happens. With just another few lines of code, we can tell our robot artist to transform that boring table of numbers into a clear, compelling chart. This code is going to take our average scores and create a graph that makes comparing them totally instant. Let's see how it's done. So first, we import the specific part of the library we need for plotting. And, you guessed it, we give it a nickname, PLT. Then, a simple command like
dot plot, kind equals bar, tells our data to draw a bar chart of the averages. We could have just as easily said pi to get a pie chart. Finally, plt.show is the command that actually puts the graph up on our screen. It's literally like telling your artist, okay, show me what you've made. So we've pretty much answered our first question about student performance. But what about that second, deeper question? Are these subjects related? Does being good at math make you more likely to be good at science? To answer that, we need to dig a little deeper and explore a really cool concept called correlation. And this is where Python just shines. It's so powerful. To find the hidden relationships between all of our subjects, you don't need some super complex formula or hours of work. You just need one single command, df.core. That's it. That one command tells pandas to figure out the relationship between every pair of subjects for us. So, what is this correlation thing anyway? Don't let the fancy names scare you. It's just a number. That's it. A single number between -1 and +1 that tells you exactly how strongly two things are related and in which direction. It's a really powerful idea boiled down to one simple value.
And here's the secret decoder ring. If the number you get is close to +1, that means you've got a strong positive relationship. When one score goes up, the other one tends to go up too. If the number is close to 0, it means there's really no connection. And if it's close to -1, that's a strong inverse relationship. When one goes up, the other tends to go down. It's that simple.
So when we run that one little command on our student grades, when we ask our data, what's the connection between math and science? What number does it give us back? It gives us this. 0.9. Now, think back to what we just said. A number close to +1 is a very strong positive relationship. And 0.9? That is really close to 1. We have our answer. The data is telling us, loud and clear, that there's a strong connection. Students who do well in math are very likely to also do well in science. We've uncovered that secret connection we were looking for.
So look at what we've done. In just a few minutes, we went from a plain, boring table of numbers to calculating performance, visualizing the results, and even discovering a hidden pattern in the data. We turned numbers into a story, and now you have the basic toolkit to do this yourself. So the only question left is, what stories will you discover next?